Hi everyone, welcome to Math 2, Unit 6. This is lesson 6.3 and we are going over activity 1. This video will cover the first question on activity 1 over here. So, we are given an image. So this image shows a circle with center 6, 10 and radius of 17 units. So I'm going to underline that because that seems important. The point 14, 25 looks like it might be on the circle. Verify if it really is on the circle. Explain or show your reasoning. So let's plot 14, 25 on our circle over here. So it'll be like roughly over 14, and then we can go up to roughly where it's about 25. And I'm going to call this point A. So I'm just going to say 14, 25. And on first glance, it looks like it falls on the circle, right? But there is actually a way for us to prove whether or not 14, 25 is actually on the circle. So first, let's start by drawing a line connecting our center point, 6, 10, to point A, 14, 25. I'm going to call this point A. We've got a line over here, and this line segment is called our radius, right? So our radius of a circle is the distance from the center point to any point on the circle. And we are actually given some information about our radius in the question. So earlier, I underlined that the radius was 17 units. Okay, so if we can prove that the distance between the center and point A is 17 units, then we can actually prove that point A is indeed on the circle. So that brings us to the question, how might we go about finding this distance, right? This is our radius over here. How will we find this distance? So since our radius is the distance from the center to any point on the circle, right, we can look back at what we did in our warm-up, where we used the Pythagorean theorem to find the distance between 2 points. So we can actually apply the Pythagorean theorem in this question to find the distance. So I'm going to create a right triangle over here connecting these 2 points. And I'm going to label my A, B, and C values as well. So remember that our C value, right, is our hypotenuse of our right triangle. And in this case, it also happens to be our radius. So I'm going to write that down over here as like a little arrow. So radius will be our C, or hypotenuse in all right. So next, we need to find these side lengths, right? We got to find our A and B so that we can then plug them into our Pythagorean theorem, A squared plus B squared equals C squared. So I'm just writing that up there so we have it for reference. So remember in the warm-up where we found the third point on the right triangle, right? This point using the coordinate pairs of the other 2 points. So I want you to pause this video and try to find this coordinate pair from the work that you did in the warm-up. Okay, so we can infer, right, from this point over here that the x-coordinate is 14, right, because the y-coordinate, we can infer that the x-coordinate of this point is 14 because it is on the same line as point A, right, and point A also has the x-coordinate of 14. We can infer that the y-coordinate is going to be 10 because it's on the same line as the center point, right? And they both have the same y value at 10, they just have different x values. So this coordinate pair is at 14, 10. Now that we have all the coordinate pairs in this triangle, we can start to find the side lengths. So pause the video and try to find the side lengths of A and B. And you can look at your warm-up if you need a review. So first let's look at the side length A. Our x coordinates are exactly the same, so we're going to be looking at our y-coordinates here, right? So if we look at this distance, we can just subtract our 25 and 10, right? This is the change in vertical distance. So I'm going to write 25 minus 10 over here. And then when we look at the b value, right, this is our horizontal distance, we see that our y-coordinates stayed the same, but this time our x-coordinates changed. So I'm going to circle our 14 and our 6 here. So this distance, right, is going to be our 14 minus 6. So I'm actually going to draw this triangle out again so that you can clearly see the side lengths. So we've got C, right? We know that 25 minus 10 is 15. We know that 14 minus 6 is 8. So we've got our A value of 15, B value of 8, and now we need to solve for C. So let's plug these into the Pythagorean theorem and start to solve. And remember, our Pythagorean theorem is up here, a squared plus b squared equals c squared. So I'm going to put 15 squared plus 8 squared equals c squared. We know that 15 squared is 225, right? That's 15 times 15. 8 squared is 8 times 8, so that's 64. When we add up 225 and 64, that gives us 289 equals c squared. And then remember this last step, we can take the square root of both sides. The radical and the exponent cancel out, and we're left with c equals the square root of 289, which is actually 17. Great. So I'm going to write this down in the sentence, because we proved the hypotenuse is 17 units. Point 1425 lies on circle. All right, so because this hypotenuse, it represented the distance between the center and this point 14 comma 25, and that was our radius. All right, so because we proved that yes, indeed, this distance is 17, meaning that the radius is 17, we now know that point 1425 lies on the circle. So I will see you in the next video for the rest of activity 1. Thank you.